We're now moving on to part 2 of thermal physics, and in the last presentation you remember that we discussed all the three gas laws, the Boyle's law, Charles' law and the pressure law. And if we were to combine all of those three laws, we end up with something called the ideal gas law. And the equation for the ideal gas law is that the pressure multiplied by the volume is equal to the number of moles of gas multiplied by the gas constant multiplied by the temperature. So PV equals small n RT. And for a given quantity of gas, in other words a given number of moles, PV over T will be a constant. 1 mole of gas, regardless of the type of gas it is, will have the same number of particles, and the number of particles is given by Avogadro's number, which is 6.023 times 10 to the power of 23. It's usually given the symbol n, that's capital N, followed by a small capital A. To find the number of particles, if we call that large N or capital N, in small n number of moles of gas, we use the following formula. I'm not going to read it out to you, otherwise I'll get confused with all of the different types of N in that formula. But you can see that the number of particles in a gas is the number of moles multiplied by Avogadro's number. Now Boltzmann's constant, K, is like the gas constant for one particle of gas. So the K is equal to the gas constant divided by Avogadro's number. And we defined what Avogadro's number was earlier, and we also said that the number of particles in a particular gas is equal to the number of moles multiplied by Avogadro's number. So we can rearrange that equation and find out that PV, that's pressure multiplied by volume, is equal to capital N, where N is the number of particles in that gas, multiplied by K, which is the Boltzmann's constant multiplied by the temperature, and that's called the equation of state. And that is the end of part 2.
Created using Powtoon.